The law of cosines. Before watching this video, be sure that you've watched my video on the law of sines, as we'll be using that in this presentation. Like the law of sines, we're dealing with oblique triangles. Notice the triangle ABC, angles ABC, sides ABC, where the lowercase letter is used for the side across from the given angle. So angle B across from it will be side B. And you see that there are actually three statements of the law of cosines. Study those for a moment and notice that here's what we'll be solving for. If we want to solve for A, we'll use the first one. We want to solve for B, the second, and so on. And please notice that when you're solving for side A, you will need to know the angle A so that you can take its cosine. Similarly, side B, you'll need to know angle B, and to find side C, you'll need to know angle C. This first example is what's called a side angle side triangle, or SAS. What do we mean by that? Well, we have here a side that we know, 20. We then know the angle, and then we know the very next side. So the angle that we know is between the two sides. Now suppose we tried to do this using the law of sines. Well, we'd have a problem. In order to work the law of sines, you need, in at least one of your fractions, you need to know the side and then its corresponding angle. Well, we don't know side B here. So law of sines just wouldn't do us any good. Instead, we're going to use the law of cosines, the three forms of which I already have appearing on this slide. Now let's see which one we'd want to use. Well, the only angle we know is angle B, so we would need to use the middle form. Since we know angle B, we could work out its cosine. So this is what we're going to use, and notice that this can be used to find B. If we can find B squared, we can take the square root and get B. So let's use that middle formulation there. We would have B squared equals A squared, that's 28 squared, plus C squared, which is 20 squared, and then it's minus 2A, 28, C, which is 20, and that would be times the cosine of angle B, or the cosine of 60 degrees there. Now you might be tempted to start putting that in your calculator right now, but instead I'd like to first solve this for B before I reach for the calculator. To solve this for B, we would want to take the square root. That then would give us B. Now of course we also have to take the square root of this long formula here. That's what you want to enter in your calculator. You want to let this be a one-step calculator problem. So you start out with the square root, and then you start to enter all this. Like the law of sines video, I rounded things to 1 decimal place, so I'll do the same thing here. I see that my screen shows me 24.97 on my calculator. That would round up to 25.0. Okay, so we got that first thing done. Let's progress a bit further. I labeled that 25.0 there. Now, what don't we know? We don't know angle A, and we don't know angle C. Well, I'll tell you, with a side angle side triangle, after first using the law of cosines in order to get one of the sides, the order can matter in what you do next. What I want you to do is I'll write it out for you, use the law of sines next, and use it to find the angle, use it to find the angle across from the shortest of the given sides. Find the angle across from the shortest of the given sides. Well, what was given? 28 and 20 were both given, so the angle across from the shortest of the given sides would be over here, this C. Well, here I pulled up the law of sines so that we can do that. All right, let's use the one involving C here, right here. And so that would be 20 over the sine of C. And yes, I do realize we certainly don't know the C there, so we can't put a number there. So for the other, we just want to make sure that we know everything in the fraction, because you only want one unknown in an equation. Well, since the only angle we currently know is 60, which is B, we will have to use this fraction here involving B. So this would be 25 over the sine of 60 degrees there. Let's cross multiply. We will have the sine of C, well, times 25, and the other cross product would be 20 times the sine of 60 degrees. Let's solve for the sine of C. That would be 20 sine of 60 degrees over 25. Now we don't want to put this yet into our calculator. We want to first algebraically solve for C. Now the way it works there is we want to get rid of the sine in front of C. You can do that by applying its inverse. Now what's the inverse of sine? Well, inverse sine. So if you apply, I'll write it in here in red. I might have to write it a little small on the right. You'll apply inverse sine, to both of these. On the left-hand side, sine and its inverse will cancel out just to C, and on the right-hand side, you'll have inverse sine of that fraction there. And this is a statement you'd want to put in your calculator. First pull up the inverse sine with the parenthesis, and then put the inner part. Make sure that you're in degree mode for this problem. And here's what I got using the convention of rounding to one decimal place. I got 43.9. That's an angle, so that is degrees. All right, so C is 43.9 degrees. Notice the last thing, angle A, can be found once again by just taking 180 degrees and subtracting the other two angles, and what that will give us is a 76.1 degrees, and we have solved this problem. This example is of what's called a side-side-side triangle, or SSS triangle. Rather self-explanatory. You know the measures of the three sides, but you don't know any of the angles. Please notice that although the law of sines is nice to use because the formula is so simple, we can only use it if we know at least the measure of one of the angles. So we couldn't use the law of sines yet. We're going to have to go and reach for the law of cosines, which I'll bring up here. Now we have to select one of these to use for the problem. Very important matter. When using a law of cosines, it's, as you saw in the last problem also, sometimes critical the order you follow. Here's what you do with an SSS triangle. First, you go and you find the angle opposite the longest side. Now what's the longest side in this problem? Well, it would be 9, so the angle opposite the longest side would be angle C here. Okay, that's always the first step with side, side, side. So let's start plugging in and see what happens. C squared, 9 squared, equals A squared plus B squared. That's 5 squared plus 6 squared. Minus 2AB. That's 2 times 5 times 6. And then finally, cosine of C, and of course we don't know C there. Notice there's one unknown in this problem. It's angle C. Before I reach for the calculator, it will help if I do a little bit of the arithmetic, simplify things a bit. 81 equals 25 plus 36 minus 60 cosine of C. Now that's 81, and 25 and 36 give 61. We can take away 61 from both sides to give us that 20 equals minus 60 cosine of C. If we divide both sides by minus 60, we will have that the cosine of C equals negative 20/60. I could reduce to negative 1/3. Won't matter so much since I'm going to reach for a calculator sooner or later. Now this gives us cosine of C. We don't want to know cosine of C, we want to know C itself. So what we'll do is we'll take the inverse cosine on the left and on the right. When you take inverse cosine on the left, inverse cosine and cosine cancel out and leave you C. On the right, when you take, why did I start writing sine? On the right, when you take inverse cosine, you will be taking it of the negative 1/3. Reach for a calculator, degree mode again, round to 1 decimal place. At least that's what I've decided to do on these problems. And what you have is 109.5. Okay, so angle C, of course, is more than a 90-degree angle, almost 110. Let's continue with this problem. Okay, I filled in what we just solved on the last slide, and now we need to find either angle A or angle B. Well, okay, with a side, once you've used your law of cosines the first step, it will not matter which of the other ones you find next. Won't matter, so hey, I'll just find A. Now the nice thing is we can reach for the easier law of sines now since we know both angle C and side C. So in order to find out what A is, that would be side A, which is 5, over the sine of angle A, and then using this third fraction which we have information for, that would be 9 over the sine of 109.5 degrees. As always, cross multiply. 9 times sine of A equals 5 times the sine of 109.5 degrees. Divide by 9. And you have this. And now we have sine of A, we just want A, so we have to apply inverse sine to the left and the right. That will give us A equals inverse sine of this whole fractional expression here. Degree mode, round to 1 place, and rounding I got 31.6 degrees. Good. Well, what's left? Let's see, just angle B. Oh, you know, 2 angles, you want a third one, no problem. We just go back to the fact that they add up to 180 degrees. And angle B turns out to be 38.9 degrees. There we go. Did a fair bit of work in this lecture. So law of sines and law of cosines go together kind of in one neat package, and you can use them to solve for missing angles or missing sides of a triangle. Good luck.